Stoichiometry problems in chemistry refer to problems that ask about the quantities of reactants and products in a chemical reaction. The first step in a stoichiometry problem is to make sure that you have a balanced chemical equation. Remember that the balanced chemical equation is like a recipe. It tells you what ingredients, or reactants, you will need, and what new materials, or products, you will make. The balanced chemical equation also tells you the amounts of each reactant and product in units of moles. Let's look at a specific example on the next slide. The balanced chemical equation for the combustion of liquid pentane is shown. Pentane has the formula C5H12. It will react 1 mole of pentane will react with 8 moles of oxygen to produce 5 moles of carbon dioxide gas and 6 moles of liquid water. What kinds of questions can we ask and answer using the ideas of stoichiometry? We can ask how much carbon dioxide will be produced in the reaction. We could ask how much oxygen is needed to burn a certain amount of pentane. The answers to these questions are based on the mole-to-mole relationships, the recipe, shown in the balanced chemical equation. For example, the balanced chemical equation tells us that 5 moles of carbon dioxide are produced for every 1 mole of pentane burned. Similarly, 8 moles of oxygen are needed for every 1 mole of pentane. A useful way to organize your thoughts on stoichiometry problems is to realize that all stoichiometry problems involve mole-to-mole relationships. These are the heart of any stoichiometry problem. The coefficients in the balanced chemical equation allow you to make connections between any two reactants or products in the reaction. The relationships are always given in moles. Many times there will be additional connections that you have to make in the problem. For example, converting moles to grams or vice versa. Remember that we've already learned that you can use molar mass to convert between grams and moles. Another relationship involving moles that we have learned is the use of Avogadro's number to convert between moles and individual molecules. Later in the semester, we'll learn additional relationships involving moles. Here are some sample stoichiometry questions to try. The following videos will show these examples worked out.